Hello everyone! Today we are going to be talking about chemical reactions and the conservation of mass. So what I want you to get out of this lesson today, we're going to continue to look at evidence for chemical change, and I want you to be able to also explain how matter is conserved during a physical and chemical reaction. So keep those in the back of your head as we go through this. So when I talk about chemical change, that's kind of what we were talking about last week, right? Another way we can say that is a chemical reaction. This is when a substance goes through a chemical change. So I think last week I kind of used them a little bit interchangeably. But yes, chemical reaction is like when a substance goes through a chemical change. During a chemical reaction, the original substance, that first thing that we had, is chemically changed into a new substance. So those elements in the original thing that we had are rearranged to make something new. For example, like our hydrogen peroxide demo that I did at the very beginning of class last week, I had my hydrogen peroxide, and then I made some sort of reaction happen, and I got water, H2O, and oxygen afterwards. So my hydrogen peroxide was changed into something new. It was changed into water and oxygen. So a way that we can show this happening is through a chemical equation. A chemical equation is the shorthand way of describing what substances go into a reaction and what substances come out of a reaction. So it's usually written in a chemical formula, and maybe we'll recognize this vocab word of chemical formula. That is the thing that we write out when we're talking about compounds and molecules, right? So like my hydrogen peroxide, H2O2, that's the chemical formula for hydrogen peroxide. So when we have a chemical reaction and we're writing the chemical equation for that reaction, we have two things. We have a reactant, and that's the initial substance, that first thing that we have. So that'd be like my hydrogen peroxide is called a reactant. Then we have our product. Our product is a substance that we have after our reaction. So our reactant becomes our products. Our hydrogen peroxide becomes water and oxygen. The reactant goes in and the product comes out. So another thing that is important about chemical equations is that they tell us how many molecules are used in the reaction and how many are created. They do this by using something called a coefficient. So that's a number in front of a molecule that tells you how many. So for example, we have our oxygen molecules, our O2, so that's two oxygen bonded together. And I have a little 2 in front of it, and that means that I have two O2 molecules. So one molecule, and then I have my second molecule down here. Same with over here, I have an H2O, so that's our water molecule, 2 hydrogen bonded to 1 oxygen. So here's 2 hydrogen and our 1 oxygen, and this 2 in front of it, our coefficient, means that I have 2 of those. I have 2 separate water molecules. So these are our reactants, right? Those are the thing going in, and these are our products. These are the things that come out. So when we talk about the law of conservation of mass, this means that mass is never created or destroyed in a chemical reaction. So when we put a reactant in and we get a product out, it's the same number of elements that are going in as they are coming out. So the number of elements are the same before and after. If you want to explore this a little bit more in depth, if you open up this presentation in Google Classroom, you can click on this video, and I have another video through TED Ed that explains this a little bit more into detail. So if this is something that you need to explore a little further, give that a watch. But for my law of conservation of matter, I have this down here. I have 2 hydrogen and 2 oxygen that are reacting. This is our reactant side, right? And they go in and they become 1 water molecule, so 1 oxygen, 2 hydrogen, and 1 oxygen. But if you count them, they're the same number of atoms. So I have 2 hydrogen atoms on this side, I have 2 hydrogen atoms on this side. If we go back to our reactants, I have 2 oxygen atoms on this side, and I have 2 oxygen atoms on this side. It's the same number of elements, they just got rearranged. So when we're looking at a chemical equation and we're thinking about the conservation of mass, you need to make sure that the equation is balanced. And that means that there are the same number of atoms on one side as there are on the other. So if we have our hydrogen, we're going to stick with our hydrogen peroxide example that's turning into water and oxygen. Is this balanced? Let's count. So if we look at our reactant side, our hydrogen peroxide side, we have 2 hydrogen, right? Because we have a little 2 down here. So 2 hydrogen atoms, and we have 2 oxygen atoms. If we go to our product side, we have, let's see, 2 hydrogen atoms. We have 1 oxygen here, and we have 2 oxygen here, meaning we have 3 oxygen. So this isn't balanced because we have 2 hydrogen, 2 oxygen on one side, and we have 2 hydrogen and 3 oxygen on the other side. So how can we balance that? This is when that coefficient comes into play. We can add a coefficient, so a number beforehand, to increase our number of molecules so that our number of elements and atoms on each side are the same. So now I have 2 hydrogen peroxide molecules, right? So if you just multiply by that number to get the number of atoms. So I had 2 hydrogen times 2 is 4, 2 oxygen times 2 is 4, and let's count them on this side. So we have 2 hydrogen times 2 is 4. I have 1 oxygen here times 2 is 2. And then I have 2 here. So I can, my 2 oxygen that I multiplied plus the 2 here equals 4. Now that matches the same on this side. So I'm going to walk through one of these with you, and then I want you to do the other as practice, and then you can go into this presentation, or I will reveal it at the end to show you. So I have 1 SN molecule, or 1 SN element, atom on this side. Let's count them up. I have 1 SN element, atom on this side. So 1, 1. That checks out. That's the same. How about my oxygen? I have 2 oxygen atoms on this side. I only have 1 oxygen atom on this side. Interesting, okay? Continue. 2 hydrogen on this side, 2 on this side. So it's really the number of oxygen molecules that are off, right? Because we have 2 on this side, but we only have 1 right here on our product side. So what do we need to do to make that the same? I'm going to take this away and reveal. So what we can do is we can add our coefficients, right? So if we add, we want to start, so we will have 2 oxygen on this side, we want 2 oxygen on our product side. So we're going to put a 2 in front of it to make our 2 oxygen. But now we have to multiply our hydrogen by this 2 as well. So now we have 4 hydrogen. So now we go back to the other side and we put a 2 in front of our hydrogen molecule to make sure we have 4 over here as well. So now we have 1 SN on each side, 2 oxygen on this side as well, 4 hydrogen, because 2 times 2, 4, and 2 on this side as well. 2 times 2 is 4. So now it is equal. I'm going to put this back. Now I want you guys to look at this one. We have 2 nitrogen and 2 hydrogen. But now on this side we have 1 nitrogen and 1 hydrogen. I want you to pause the video, take a moment, think about how you would make those the same, and then I will reveal it. Okay. Is this what you got? Double check your answer. Okay, that's what I have for you today. I know this was kind of a long video. That is all I have. I will see you guys later.